Hello, this is Purohit and I welcome you back to my YouTube channel. Now this is another video which is based on practicals of inorganic chemistry. In the previous two videos, I have explained you about the inorganic preparations. Alright? Now in today's case, we are going to discuss about the qualitative and quantitative analysis of mixture. Okay? So once again I repeat, it is qualitative and quantitative analysis of mixture. And this mixture is going to be a mixture of salts. Now, you are very much clear with the terms qualitative as well as quantitative. Okay? I have a particular substance, and if my aim is to find out what it is made up of, then I will call it as what? Qualitative. But if my aim is to find out how much amount of this substance is there, then I call it as what? Quantitative. Alright, so this is the approach when we carry out qualitative and quantitative analysis. Here in this TYBSc syllabus, you are supposed to carry out qualitative as well as quantitative analysis of a mixture of salts. When I use the word mixture, it is very evident that it is at least made up of two. But here, according to the syllabus, it is two. Two salts. What do you mean by salts? Salts are generally combination of a cation as well as an anion. Okay, those are called as what? Salts. Except of course you don't consider H plus and the OH minus, because then it becomes an acid as well as a base. Okay, so this is what a salt is all about. So we are going to consider two salts. One is going to be in a major proportion, the other is going to be in a minor proportion. So first of all, I just explain you how to proceed as far as the analysis is concerned. So let us consider one salt, that is say AB. Okay, and it is going to be in a major proportion. The second salt is going to be CD, which is obviously in a minor proportion. Now, as I told you, the salts are made up of cations as well as anions. So, this is made up of a cation, say A plus, and an anion, say B minus. Similarly, the salt which is in a minor part, that is also made up of a cation, that is C plus and D minus as the anion. So, I have two major, that is a cation as well as an anion, and I have a major cation, minor cation as well as a minor anion. Okay? Now what are we going to do is, the major cation, this has to be carried out, identification has to be carried out quantitatively. Determination has to be done, or estimation has to be done, and that is quantitatively. Okay? I hope you understand the word now, quantitative. Whereas these parts, that is the B minus, C plus and the D minus. That means what? The major and the minor anion and the minor cation has to be estimated qualitatively. And that is going to be through the semi-micro qualitative analysis. But please remember that the analysis is basically going to be through the wet test. Of course, it all depends upon the examiner as well, what he or she is going to demand from the students. But then generally, qualitative analysis of the anions is going to be done only by means of what? Wet test. We are not going to carry out the dry test. Okay, it is only wet test. So in this way you can see, quantitatively it has to be major cation, and qualitatively the major and the minor anion as well as the minor cation. This becomes the entire framework of this particular experiment. Alright, so I once again repeat what exactly has to be done. We are discussing right now about the qualitative and the quantitative analysis of a mixture. What mixture we are talking about? Mixture of salts. Okay, and also we are going to consider water soluble salts. So please keep this in mind that we are going to use water soluble salts, and as a result of which, for the solubility purpose, we are going to use what? Water as a medium. Now, I am giving you just a schematic explanation of this. Now, let's suppose I have a mixture of two salts, AB as well as CD. The proportions are different, so obviously one of them will be major, the other will be minor. So, AB let us consider is major, CD is minor. Okay, then I bifurcate into the respective cations as well as anions, and as a result of which I will be naming those as major cations and the minor cations and the major anions and the minor anions. Next, this A plus is going to be a major cation that is going to be estimated quantitatively. Okay, generally we carry out volumetric estimation. Of course, I will be explaining you this in the later part of this video. And then what remains are the anions, that is the major as well as the minor anion, along with the minor cation that has to be estimated qualitatively, and generally the step which is to be performed or followed as far as the qualitative analysis is concerned, and that is only the red test. Okay, so this is the entire experiment which has to be performed apart from inorganic preparation. So these are the two major types of experiments in SEM 5 inorganic chemistry practicals. The first one is inorganic preparation, where we were looking into that particular part from the quantitative approach. Here we are looking into from both the quantitative as well as qualitative. Also, my dear friends, what we have to consider over here is, once I find out the amount, then obviously on the basis of amount, I can also identify the purity. Okay, so we need to go one step ahead, and that is we need to find out the percentage purity of the major cation which is going to be present in the mixture. Alright, so I hope you have understood this scheme of experiment very well. Now, my dear friends, we go into the quantitative analysis. I hope you remember this. Major cation has to be estimated quantitatively. Alright? So here I am going to explain you the quantitative analysis of nickel, okay, which is considered as a major cation. So the steps involved in the estimation are: step number 1 is we are going to take a mixture which is approximately going to be in a range of 0.5 to 0.7 grams. Well, of course, but whatever mixture that you are going to take, you are going to actually record that weight. Okay, now please keep this in mind. Okay, suppose if you are taking as 0.653, so please keep that in mind, 0.653, because you remember that finally we are going to find out the percentage purity. So we require the weight of the mixture, accurate weight of the mixture. Okay, but then it has to be in the range of 0.5 to 0.7 gram of the mixture has to be taken. Now, since as I told you few minutes back, and that is the mixture has to be water soluble. So obviously we need to make sure that this is going to be soluble, and the amount of water should be in the range of around say 25 to 30 cm3. Now this has to be done in a beaker. Okay, it has to be done in what? In a glass beaker. So once again, let it be on a watch glass. We are going to weigh the mixture. It should be in that range. Okay, but please record the exact weight. Next, through the watch glass where you have weighed the mixture, transfer it into a beaker. Take around 25 to 30 cm3 of water. Okay, stir it very well so that it is going to be what? Soluble. So what is this? 25 to 30 cm3? It's water. Okay. Now what you do is you transfer this into 100 cm3 of SMF. I hope you understand this. Standard measuring flask. Okay, you have to transfer that into it. Give some washings also to the beaker, of course with respect to water, so that we are making sure that each and every part of the salt gets transferred into the standard measuring flask, and then finally you are going to dilute it up to the mark. Okay, so this is what we have, a solution of the cation. And which cation am I talking about? Yes, it's nickel 2. It's, my dear friends, titration. So when you talk about titration, my dear friends, we require two solutions. So one solution is ready, which is in a standard measuring flask. Now we go into the burette solution. So the burette solution is EDTA, ethylene diamine tetraacetic acid. Okay, now this is going to be a standardized EDTA. Please remember this. Standardization has to be done by using 0.01 molar zinc sulfate. Okay, and you calculate. You know the calculations very well. N1D1 is equal to N2V. When accordingly you calculate and you find out the exact normality of a EDTA. Okay, and then that will go in where? In the building. Okay, clear up to this? Right. Next part. We have the standard measuring flask containing the solution of nickel. Okay, it is 100 cm cube. So what are we going to do is, from this, you are going to prepare out 10 cm cube. Please prepare out that. Where? Into a conical flask. I write it down as what? CF, conical flask. Add to it around say 1 test tube of distilled water. Next, add to it 5 to 6 drops of murexide indicator. Now the reaction has to take place in a basic medium, and also we need to use a buffer also over here. So for that purpose, we are going to take half a test tube of 1 molar ammonium chloride, and to which you are going to add liquor ammonia till the color of the solution becomes yellow. Okay, because the color indicates the pH range in which the reaction is being carried out, so that you get a constant burette reading, which is so very important. Alright, so once again I repeat, the 10 cm cube of the diluted solution is being prepared out in a conical flask. Add to it 1 test tube of distilled water, 5 to 6 drops of murexide indicator, half a test tube of 1 molar ammonium chloride and liquor ammonia till the solution is what? Yellow. Also add slightly excess of liquor ammonia. Alright? Now titrate. Now the titration has to be done. With whom you know it very well, and that is going to be your EDTA from the burette. So titrate this solution. Now when you titrate the solution, already the indicator is there, that is murexide. So once you have a solution in the burette, you also have a solution in the conical flask, you have an indicator, then what is the next step is, yes, you need to know the end point. Okay, the color change. So the color change will be, I already told you that the liquor ammonia has to be added till the solution is what? Yellow. So obviously the initial solution color will be what? Yellow. Start titrating it, addition of EDTA through the burette till what? Till it gets converted into a bluish violet. Okay, and record this reading and whatever the reading is there, so that please record it. And then what has to be done is, okay, after that is repeat this procedure 2 times so as to get what? The CBR, that is constant burette reading. On the basis of the constant burette reading, on the basis of the value of what? W, it is then possible for us to find out the percentage purity of nickel. Understood this? Okay, once again I recap the entire procedure, and that is, we are going to carry out the quantitative estimation of nickel, alright, which is a major cation. So we are going to take the mixture in this range, we are going to dissolve it in 25 to 30 cl cube of water. Okay, so the mixture has to be taken in a watch glass, it has to be transferred into a beaker, alright, and then what you have to do is add around 25 to 30 cl cube of water, stir it so it gets soluble, so we get a solution form. Next is you transfer that solution into a standard measuring flask, give the washings to the beaker, okay, with the help of distilled water, and then dilute it up to the mark. Next thing is the burette is being filled with EDTA. Now, please remember the EDTA has to be a standardized form. How to carry out the standardization process? By titration against 0.01 molar zinc sulfate. Alright? Next, the 100 cl cube of the standard measuring flask solution. Okay, it is containing what? Fe2 plus solution. Nickel 2 plus solution. Now what you are going to do is, you are going to prepare out 10 cl cube of that in a conical flask. Add around 1 test tube of distilled water to it, and then the indicator is going to be a murexide indicator, 5 to 6 drops, and to create a basic medium and also to make sure that we get a CPR. So we are going to use a buffer solution. So a basic buffer which is in the form of half test tube of ammonium chloride and then liquor ammonium. How to identify that yes, this much amount of the buffer solution is enough? By means of what? Color. So make sure that the color is what? Yellow. Till then you are going to do the addition of liquor ammonium. Once that is been done and then titrate it till the color changes yellow to bluish violet, and you repeat this for 2 more times. So you get 3 readings, out of which the 2 has to be constant, and that reading is called as CPR, that is constant butyric reading. And as I said, on the basis of the constant butyric reading and the value of W, it is possible to find out what the percentage purity of nickel, which is considered as a major cation. So I hope you have understood these steps very well. So my dear friends, you have understood the theoretical part about how exactly the execution is being done. Now I am going to practically demonstrate the quantitative part. I hope you remember what am I talking about quantitative is. Yes, it's about the major cation. Alright. So here we have a mixture, okay, which has to be made how much? 0.5 grams. Now I'll tell you over here, because see what happens is whenever we have to carry out the quantitative analysis of a major cation, so it's very obvious you need to know which major cation is present. Okay, because here it's not qualitative, it is quantitative. Okay, so depending upon the nature of the cation, a particular volumetric technique is followed. Okay, with respect to the chemicals and the reagents required. So here I have to declare that the major cation is nickel. Okay, the major cation is what? Nickel. So I am going to take this mixture of 0.5 grams and I am going to dissolve it. So initially I am going to just take around 25-30 ml of water so that it gets completely dissolved, because as per the syllabus we are supposed to take a water soluble salt. So we are going to stir this so that it gets dissolved completely. Yes, so you can see this. It's dissolved. Now what I need to do is, I need to transfer it into a standard measuring flask. Always hold the standard measuring flask to your eye level so that you can clearly see the markings. Alright, now give some washings also to this beaker so as to ensure the entire amount of the mixture is getting transferred into the solution form, and eventually it is going to be into the standard measuring flask. Alright. So see this beaker is absolutely clear now. Okay. Now we go for the final dilution. We are going to dilute it to 100 ml. As I told you, please hold the standard measuring flask to your eye level. This time it's exactly being done. Now cork it, and you just have to stir it like this so as to ensure homogeneity. So this is our solution. Okay, that is a mixture containing our major cation, that is nickel. Now, next thing is the titration part. The titration has to be carried out with what? EDT. EDT is over here in the burette. And if you remember, I told you in the theoretical part as well that this EDTA is a standardized EDTA. we have already standardized against 0.01 molar zinc sulfate. Okay, so that standardized EDTA goes into the burette. It's being adjusted already to 0 level. Now what we need to do is the solution of the mixture is very carefully open the cork and prepare out 10 ml. This is a 10 ml pipette. So you are going to prepare out 10 ml of this solution into this conical flask. So this is the 10 ml of the solution which I am going to transfer it into the conical flask. So just tap it. Now next thing is we are just going to add around say for some amount of water into this, so that the color change becomes much more apparent. Next is half test tube of ammonium chloride. I already told you in my explanation that the reaction takes place in a basic medium. So we are using ammonium chloride and we are going to use ammonia so that it behaves as a buffer and as well as it creates a basic medium. So slowly we are going to add ammonia. Okay, now we are going to add some murex-oxide indicator. Around 5 to 6 drops of murex-oxide indicator is being added. We need to add still some amount of ammonia into this. Okay, so see this, you get a yellow coloration on addition of ammonia. So this makes sure that the pH is adjusted. Now we come over here and we start with the titration. As I already told you, this is EDTA. So the titration has to be done along with again CDTA, standardized EDTA. And I hope you know the color change. Yes, it is going to be yellow to the bluish violet color. So we start with drop by drop. We'll adjust it and then continuous stirring needs to be done. So my dear friends, see this. Okay, you got a color change and that is bluish violet. Alright? And the reading which we can see is going to be 16.2. Okay, so this is the end point that we are getting. Okay, and this has to be now done how many times? Yes, 2 more times. So total 3 readings, out of which 2 has to be constant. And that is going to be reported as what? CBR. And then on the basis of this CBR value, on the basis of the W value, yes, that is 0.5 grams which I have taken the mixture initially. So on the basis of these 2 values, we will calculate the percentage of the nickel present in the given mixture. Alright, so I am sure you are very much clear with the quantitative analysis of the major cation present in the mixture of two salts. Thank you very much.